What if I told you that somewhere in the universe, right now, a dinosaur might still be walking across the Earth? It sounds impossible, but stay with me, because this simple thought experiment completely changes how we understand time, reality, and our place in the universe. Imagine you are sitting on a distant planet in the Virgo cluster, about 65 million light years away from Earth. You have a telescope so powerful that it can see forests, mountains, and continents on our planet. You adjust the focus and point it toward North America. What do you see? You don't see highways, cities, or people. Instead, you see a Tyrannosaurus rex moving through thick jungle in a place we now call Montana. You see giant plants swaying in the wind, and the Earth looks wild and untouched. Now here's the unsettling question. Is that dinosaur real? You might immediately say no. After all, dinosaurs are long gone. Their bones sit in museums. Their time is over. But think carefully. The alien watching through that telescope sees the dinosaur alive and moving. The light carrying that image is reaching their eyes at this very moment. For that observer, the dinosaur is happening now. From our point of view on Earth, dinosaurs belong to the past. From the alien's point of view, they belong to the present. So which one of us is correct? This question forces us to confront something deeply uncomfortable. It suggests that past, present, and future may not be universal truths. They might depend entirely on where you are and how you observe events. Time may not flow in the simple way we imagine. Instead, it might behave more like a loaf of bread that can be sliced in different directions. Depending on how you cut it, different pieces line up as now. Before diving into the strange geometry of space-time, let's begin with something familiar. Look at your hand and move it slowly. It feels like you see it move instantly. Your muscles contract and your eyes register the motion at the same moment. But that's an illusion. The light reflecting off your hand takes a tiny fraction of a second to reach your eyes. It's only about a billionth of a second, so your brain treats it as instant. But technically, you are always seeing your hand as it was a moment ago. You are never seeing the present. You are always seeing the past. That delay seems meaningless at small distances. A billionth of a second doesn't matter when you drink coffee or tie your shoes. But when distances grow large, the delay becomes enormous. To understand how big, we need to go back to the 17th century and meet a clever astronomer named Ole Romer. In 1676, Romer studied the moons of Jupiter, especially Io, which orbits Jupiter with incredible regularity. Every 42.5 hours, it disappears behind the planet like clockwork. But Romer noticed something odd. When Earth was closer to Jupiter, Io appeared exactly on schedule. When Earth was farther away, the moon seemed to arrive late. It wasn't just a small delay. It was consistent and measurable. Romer realized something revolutionary. The moon wasn't late. The light was late. The image of Io had to travel across space, and that journey took time. When Earth was farther away, the light had to travel longer, and the delay grew. From this observation, Romer concluded that light has a finite speed. It isn't instant. It travels, like a messenger crossing a vast distance. This discovery shattered the old belief that light appears everywhere at once. Instead, it revealed a universe where information takes time to move. And that means every time we look into space, we're not seeing the present. We're seeing history. And once you accept that idea, the universe starts to feel very different. And once you accept that idea, the universe starts to feel very different. Because if light takes time to travel, then every time you look at something far away, you're seeing it as it used to be, not as it is. When you look at the sun, you are seeing it as it was 8 minutes ago. If the sun somehow vanished this instant, we wouldn't know it yet. For 8 full minutes, the sky would still glow, the earth would stay warm, and gravity would hold us in orbit. Only after those 8 minutes passed would the darkness arrive and the effects follow. That delay between reality and perception is built into the structure of the universe. At first, this sounds like just an interesting detail, but it's actually the beginning of something far more profound. Because once we accept that light moves at a limited speed, we have to ask a deeper question. Speed relative to what? In everyday life, speeds add together in a simple way. If you throw a ball forward at 100 miles per hour while standing on a train moving at 100 miles per hour, someone watching from the ground sees the ball moving at 200 miles per hour. That's common sense. That's how motion works in the world described by Newton. But light refuses to follow those rules. If you shine a flashlight on a train moving incredibly fast, the light leaving the flashlight still travels at the same speed. And if someone stands outside watching, they measure the light traveling at that exact same speed as well. It doesn't matter how fast the source moves. It doesn't matter how fast the observer moves. The speed of light is always the same. This should feel impossible. If you run toward a beam of light, shouldn't you measure it moving faster? And if you run away, shouldn't it appear slower? That's what happens with sound waves or thrown objects. But light ignores those expectations completely. There is only one way for this to make sense. If the speed of light cannot change, then something else must change instead. Space itself must adjust. Time itself must adjust. Lengths can shrink. Clocks can slow down. The very measurements we use to describe reality have to shift so that the speed of light remains constant. This is where we stop thinking of space and time as separate things. Instead, we start thinking of them as parts of a single structure. To picture this, imagine a long sausage lying on a table. If you slice it straight across, you get a neat circular piece. Let's say that slice represents everything happening at one moment in time. Now imagine tilting the knife and slicing at an angle. The slice becomes oval-shaped, and it includes different pieces from different parts of the sausage. That's what motion does to time. When you move relative to someone else, you are effectively tilting your slice through the universe. What counts as now for you isn't the same as now for someone moving differently. Your present can include events that another observer would place in the past or future. This idea may sound abstract, but it leads directly back to our alien in the Virgo cluster. Suppose that alien is sitting perfectly still relative to Earth. Their slice of now might line up with our current century. They just can't see it yet, because the light hasn't arrived. But now imagine the alien starts moving away from Earth, even at a slow speed. That motion tilts their slice of space-time slightly, because the distance is enormous, 65 million light-years. Even a tiny tilt shifts which events on Earth count as simultaneous with the alien's present. Their now might suddenly align with the age of dinosaurs. In that sense, the alien's present includes the Jurassic world. If they turn around and move toward Earth, their slice tilts the other way. Now their present might include events in our distant future. From their perspective, those future events are just as real as our present moment. And if different observers can disagree about what exists right now, then we're forced to consider a shocking possibility. And if different observers can disagree about what exists right now, then we're forced to consider a shocking possibility. Maybe the past hasn't vanished at all. Maybe the future isn't empty. Maybe every moment that ever happened, and every moment that ever will happen, exists together in one enormous structure. Physicists call this idea the block universe. Instead of time flowing like a river, reality may be more like a complete landscape already laid out. We simply move through it, experiencing one slice at a time. Think again about that sausage. If each slice represents a now, and different observers cut it at different angles, then no single slice can claim to be the only real one. Your present might be someone else's past or future. That means all slices must exist in some sense. The dinosaurs, ancient civilizations, today's world, and events thousands of years ahead may all occupy different locations within the same four-dimensional structure of space-time. This idea feels deeply unsettling because it clashes with our everyday experience. We feel as if the present is special, as if the future is unwritten and the past is gone forever. But the physics of light and motion suggests that this feeling may just be a result of our limited perspective. To understand why this happens, we need to think about interaction itself. What does it really mean to see something? When you look at an object, nothing mystical is happening. At the smallest level, it's simply electrons interacting. Inside the sun, for example, electrons vibrate because they're hot. When charged particles jiggle like that, they disturb the electromagnetic field around them. It's helpful to imagine that field not as an equation on paper, but as something like a fluid filling space. When an electron moves, it sends ripples through this invisible medium, much like a stone dropped into water. Those ripples spread outward at the speed of light. Eventually, some of them reach your eye. When they arrive, they make electrons inside your retina jiggle, and your brain interprets that motion as light. Seeing, at its core, is just a delayed chain reaction. Something moves there, a signal travels, and something responds here. That delay is unavoidable because the ripple cannot travel infinitely fast. It has a speed limit. That speed limit isn't just a technical detail. It's what keeps cause and effect in order. Imagine if signals could travel instantly. You could send a message to someone before the event that caused it had even happened. You could know the outcome of a game before it started. Paradoxes would appear everywhere. The structure of reality would fall apart. The universe seems to enforce this limit to preserve causality, to ensure that causes always precede their effects. The delay between events creates separation, and that separation gives history its direction. But it also means something else, something strangely poetic. We are never truly in contact with the present moment. When you touch a table, you might think you're making direct contact with it. But what's actually happening is that electrons in your finger repel electrons in the table through electromagnetic forces. That interaction is carried by photons, tiny packets of light. Even across that microscopic gap, those photons take time to travel. So when you feel the table, you're feeling it as it was a fraction of a second ago. That delay is incredibly small, but it's real. Every sense we have, sight, touch, even sound, is based on signals arriving from the past. We are constantly constructing reality from information that's already old. In that sense, each of us lives inside a personal time bubble. We send signals out, we receive signals back, and by the time they reach us, the world has already moved on slightly. We are always chasing the present, never quite catching it. And when we zoom out to cosmic scales, that truth becomes overwhelming. And when we zoom out to cosmic scales, that truth becomes overwhelming. Think again about our distant alien observer. From their location, 65 million light-years away, the signals they receive from Earth are incredibly old. The light reaching them today left our planet when dinosaurs still dominated the land. So when they look through their telescope, they don't just see ancient history. They see a living, breathing world that, for them, is happening right now. This isn't just about delayed information. According to the geometry of space-time, their motion through the universe determines which events they consider simultaneous with their present moment. If they remain still relative to Earth, their slice of now might align roughly with our current time. They simply haven't received the light yet. But if they start moving, even slowly, their slice tilts. Because the distance is so vast, that tiny tilt shifts which moment on Earth lines up with their present. A gentle movement away from Earth can push their present slice deep into our past. Turning toward Earth can push it toward our future. In this framework, the dinosaurs aren't just visible because of delayed light. They exist as events that are genuinely simultaneous with the aliens present. This leads to a striking conclusion. If different observers can define different sets of events as now, then no single moment holds a special claim to existence. The entire timeline must exist together. The prehistoric forests, the battles of ancient empires, your childhood memories, and the lives of people yet to be born all sit within the same four-dimensional structure. This idea makes many people uncomfortable because it seems to challenge our sense of freedom. If the future already exists somewhere in space-time, does that mean it's fixed? Are we simply moving along a path that's already laid out? Physics doesn't answer that question directly. What it tells us is how events are arranged, not why they unfold as they do. It describes the geometry, not the meaning. A helpful way to think about it is to imagine a musical score. The entire symphony exists on the sheet of paper at once. Every note from beginning to end is written down. But the musician playing the piece experiences it one note at a time, in sequence. We are like that musician. We live inside the performance, not outside it. We experience moments in order, even if the full structure exists simultaneously. You might wonder whether there's a way to escape this structure. Could we travel faster than light and jump to different parts of the timeline? As far as we know, the answer is no. If anything could outrun light, it could also outrun cause and effect. You might arrive somewhere before you left. You might observe consequences before their causes. The universe appears to prevent that. Every time physicists search for a loophole, the laws of nature close it. So we remain bound by the same rule. Information moves at a finite speed. That limit shapes the structure of reality, preserves causality, and defines how events relate to one another. It also means that everything we know about the universe is built from delayed signals. The stars we see tonight may have changed long ago. The galaxies we observe could already be different. Our picture of reality is always a reconstruction, assembled from messages that took time to arrive. Yet, despite this delay, we've managed to uncover the structure behind it. With nothing more than observation, reasoning, and mathematics, human beings have deduced that we live inside a four-dimensional tapestry woven from space and time. And when you realize that, the night sky stops looking like a distant backdrop and starts feeling like a time machine. And when you realize that, the night sky stops looking like a distant backdrop and starts feeling like a time machine. Every point of light you see overhead is a message from the past. Some stars are only a few years away in time, while others send signals that began their journey long before humans existed. The deeper you look into space, the further back you look into history. Telescopes are not just tools for seeing far away, they are instruments for seeing long ago. This idea reshapes how we think about reality itself. We tend to imagine the universe as something happening now, in one shared moment. But the truth is that each observer experiences their own version of now, defined by the signals reaching them. There is no universal clock ticking for everyone at once. Instead, there are countless local presents, each shaped by motion, distance, and the speed at which information travels. That realization makes the universe feel both enormous and strangely personal. Enormous because it contains events spread across vast stretches of time, all coexisting in the fabric of space-time. Personal because each of us experiences only a narrow slice of that fabric. We move through it moment by moment, building our understanding from delayed signals and partial views. Even communication between people follows this rule. When I speak to you, the sound takes time to travel. When you respond, your voice takes time to reach me. The delays are tiny, but they're real. By the time you hear someone's words, they are already slightly different than they were when the sound left their mouth. We are always interacting with versions of each other from the immediate past. At larger distances, those delays become dramatic. A radio signal sent to a spacecraft near Mars can take many minutes to arrive. Conversations with such probes are never truly live. We send a message, wait, and only later receive the reply. Space exploration constantly reminds us that the universe doesn't allow instant contact. This same principle applies to every physical interaction. What we perceive as touch, sight, or sound is always a chain of events separated by time. The delay is the price we pay for living in a universe where information travels at a finite speed. Without that delay, everything would be connected instantly. There would be no separation between cause and effect, no sequence of events, no unfolding story. The delay creates structure. It allows events to follow one another. It allows history to exist. It gives us the sense of progression that defines our experience of life. And yet, despite being bound by these limits, we've managed to uncover the rules behind them. Through observation and reasoning, we've learned that space and time form a unified geometry. We've learned that motion changes how we measure both distance and duration. We've learned that no observer holds a privileged position in defining the present. This knowledge doesn't shrink the mystery of the universe. If anything, it expands it. The realization that we inhabit a four-dimensional structure filled with events spread across time invites deeper questions. What does it mean to exist in such a universe? What does it mean to make choices if the future already occupies a place in space-time? These questions go beyond physics, touching philosophy and human experience. But regardless of how we interpret them, one thing is certain. The universe is far more intricate than it first appears. What looks like a simple flow of time is actually a complex arrangement of events woven together by the finite speed of light. And understanding that leads us to one final reflection about our place in this vast structure. We are small creatures on a small planet, orbiting an ordinary star in a quiet corner of a galaxy among billions. Yet somehow, with limited senses and fragile bodies, we have managed to uncover the architecture of the universe. We've learned that reality is not just a three-dimensional stage where time flows forward. Instead, it is a four-dimensional tapestry in which every event occupies its own position in space-time. Our view of that tapestry is always incomplete. We see the universe through delayed signals, through light that has traveled enormous distances before reaching us. We never observe events as they happen in some universal present. We observe them as they were. Our entire understanding of reality is built from old information, arriving piece by piece. And yet, despite that limitation, we've deduced the structure behind it. Using logic, mathematics, and observation, human beings have realized that we are part of something far larger than our immediate surroundings. We are embedded in a cosmic geometry where past, present, and future all coexist, arranged not along a flowing river, but across a vast landscape. This perspective changes how we look at everything. It suggests that the dinosaurs are not simply gone. They occupy a region of space-time just as real as this moment. Historical events are not erased. They are fixed within the structure. Future events, too, have their place, even if we haven't experienced them yet. The universe, in that sense, resembles a complete composition rather than an improvised performance. But that doesn't make life meaningless or predetermined. Remember the analogy of the musical score. The entire symphony may exist on the page, but the experience of playing it still unfolds in time. The musician feels each note, shapes each phrase, and gives life to the performance. In the same way, our lives are experienced from within the timeline, even if the full structure exists beyond our immediate perception. There's something both humbling and inspiring about this realization. Humbling because it reminds us that our everyday sense of time is only a local viewpoint, not a universal truth. Inspiring because it shows how much we've discovered about the cosmos through careful thought and observation. We are, in a sense, explorers of reality itself, uncovering the patterns woven into the fabric of existence. The next time you look up at the stars, remember that you're not just seeing distant lights. You're looking into history. You're watching events unfold from long ago. Somewhere, perhaps millions of light years away, another observer could be seeing Earth's ancient past right now. From their perspective, dinosaurs might still roam forests, unaware of the future that awaits them. And in a strange way, both perspectives are valid, because in the geometry of space-time, every moment has its place. The universe holds them all together. Ancient past, living present, and unfolding future, woven into one continuous structure. It may not match our everyday intuition. It may feel strange, even unsettling. But nature has never promised to fit our expectations. It simply exists as it is. Our role is to observe, to question, and to appreciate the extraordinary reality we inhabit. So the next time you move your hand, watch the stars, or simply pause to think about the passage of time, remember this: you are not just living in the moment. You are part of a vast cosmic story stretched across space and time, a story written in light itself. And the fact that we can understand even a fraction of it is one of the most remarkable achievements of the human mind.